Structured query language, or SQL for short, is one of the most important skills that a developer should have. In fact, I think it is one of the most important skills that anybody working with data should know. In today's video, we'll take a deep dive into SQL roadmap and try and understand the different nuances of SQL. If you're not familiar with the language, worry not. We'll take a look at how do you want to get started, what are the best ways, what's the flow look like, what are the first things you should study, and what should you go next. Let's get started. So what I have on my screen is SQL roadmap from roadmap.sh. I've been using this website to do a lot of videos on different roadmaps from technology. Check out my previous video. Let's get started. So the first thing you need to know is, an introduction about SQL. So SQL, which stands for Structured Query Language, is a programming language which is used to communicate with databases. You can actually use it to manage databases as well, and it's really one of the oldest languages out there. It has really small syntax, and there's a couple of things it can do. You can query, which is basically the select statement where you want to get the data. There are DDLs, which can be used to define the data, which stands for data definition language. Then there's data manipulation language where you can, manipulate the data by making inserts, updates. And then there's a DCL, which is a control language where you can, manage and deals with permissions and rights and stuff. So these 3 or 4 different areas are what constitutes SQL. Now there's many different SQL products, database products on the market. You have relational databases like PostgreSQL, Oracle, MySQL, SQL Server. There are other kinds of databases as well, which is, MongoDB, graph databases, node databases, and so on and so forth. But in today's conversation, we are going to focus on SQL databases only. So really, from an introduction standpoint, you need to understand what are relational databases. And that's fundamentally, data which can be represented in the form of rows and columns, right? Rows are, rows. Columns are your column names, which define the group or something like that. So this is how the data looks like, right? So employee ID is a column, while 1, 2, 3 is rows, right? Okay, why am I opening email? I have no idea. And then you need to understand the benefits and limitations of SQL. There's a lot of concepts that you need to be aware of, like what's structured data, what are the asset properties, what is normalization, how do you scale data integrity, security, and things like that. There are some limitations associated with SQL, which are very, very critical to be, you should be aware of them. The first and foremost is complexity. Setting up databases can be really complex because as your application grows and as it, spans to handle multiple different kinds of data, not just from a nature of data, but also different columns. So let's say you have an order management system. So you start with simple product and shipping information, then you add pricing, then you add people, then you add logistics and stuff like that. And it just grows with over time. So databases, I always say that are one of the most heaviest pieces of, workers in your system. Then there's cost, schema management, and ability to handle unstructured data, horizontal scalability, and so on and so forth. You can read about all of that in this roadmap. Okay. And SQL versus NoSQL, there's always a good war going on. Please do check it out. Moving forward, you need to know basic SQL syntax. As I talked about, there's DDL, DML. I'm pretty sure there's DCL somewhere. Yeah, I think they have not categorized DCL here, but I think they talked about in the introduction. So you want to know a little bit about that. Then some basic syntax, like what are the keywords, what are the different data types, what are the operators, what are the core statements like select, insert, update, delete. From a data type, int, char, varchar, date time, boolean. There's tons of different data types that SQL has, right? It supports most it's fundamentally the most granular level of storage data, so it supports all the different data types. There's some advanced data types like blobs, which are binary large objects, clobs, which are character large objects, XML data types, and stuff like that. Then we move on to DDL. What do we do when we talk of DDL? So this create, drop, alter, and truncate table. Rename also, which is create, as the name says, create table, drop table, alter the structure of the table, where you can add in a column, drop in a column, or modify a column, and truncate the table. The difference between drop and truncate and delete is something you should be aware of. It's a very popular interview question. And from there, you really move to understanding code, right? If you are a developer, I think most of the time this is where your life is going to be, with a little bit of understanding of constraints, aggregate, and join queries. So DML is where you need to really master if you are a developer. So we have select query, and then you have the nuance of the select query, right? From what table, what are the where conditions, what's order by, what's group by, how many joins do you have, is there an having clause, is there an aggregate query, which is used to aggregate certain information. For example, you want to extract the number of people having salary greater than 50,000, so you will do a count on, and then where condition greater than 50,000 and stuff like that. So for example, here's a column for max, right? Selects max column name from table name where condition. So let's say this is the salary table, and you put max, you should get 3,000, right? And the SQL will return 3,000. So it's really a way to interact with the data, right? Ask questions with the data. That's what SQL is all about. So once you have mastered SQL, right, do practice a lot of aggregate queries, group by queries, specifically having clauses, where these are common interview questions. And then you move on to data constraints. What are the primary keys, foreign keys, unique keys, not null, different checks, cascading stuff, etc. And then you move on to join. Join queries are one of the most important things when you learn SQL. Join queries are inner join, outer join, right join, full join, self join. And joins can be used with select, update, and delete statements, basically. So what you're doing is you're taking a table A and a table B. There can be actually multiple tables, but you have a table A and table B, and basis the availability of certain data elements between the tables, you're trying to select the data. So you want a left overlap or a right overlap, and I think Venn diagrams are the best way to understand it. So if you just want to learn joins, put in comments. I'll do a quick video about SQL joins using Venn diagrams and move forward. As I talked, constraints are really important. They kind of set the relational structure part of the RDBMS. Without the constraints, it would just be a DBMS. The relational integrity will not be maintained. So it's very important to have primary keys, foreign keys, and understanding the relationship between. Now till here, if you're a developer, you should be good. And from here we want to move on to some advanced conversations like subqueries. Subquery is when you get into a complex retrieval scenario, or you want to do a recursion of sorts and stuff like that, where you want to get some data from a different table, and basis the response of that, you want to do something in the first table or something like that. So for example, I want to delete something in my table A basis some information that is retrieved from table B, right? So that's what subquery is. You need to understand couple of different types of subqueries exist, like nested subqueries, correlated subqueries, and things like that. This you can check this out for more details. And then there are advanced SQL functions. SQL can be actually extended with procedures, which is PLSQL, and some of these advanced conditions can help you to do more, or to increase the complexity of your query. For example, you can use some string functions like concat, length, replace, upper, lower, etc. You can use numeric functions like you want to calculate absolute values, rounding offs, etc. You can do conditional checks like case statements, null statement, coalesce. There is an insane amount of operations you can do with date and time, and manipulating time. And then you have a little more at your arsenal to be able to put programmable logic within your SQL query. Views are an important concept. So what you do is, what are views? Let's take a definition. So SQL views are virtual tables which don't store data directly. So basically views are queries that you save them and they are executed at runtime. So when you create a view, what happens is you say create view, and you usually have a complex query which you want to run over and over again. Views are usually used for reporting purposes, which essentially means that you will create a view with a certain kind of report. So let's say I want to have go back to my salary table, and I want to have three different kind of views, right? People having salary less than 50,000, people having salary between 50 to 1 lakh, and greater than 1 lakh. So I have three different where conditions, right? And I want to get them in three different places. So what I'll do is I'll create three views, each of them having different where condition, and this way I don't have to do the query over and over again. There's advanced concepts like materialized views, which wherein your view can actually store the data, but I don't think we are talking about that in this roadmap. Then you move on to understanding indexes and doing a little bit of query optimization. These are further advanced area. Typically you have started with interacting with data, working with data, manipulating data, and then you have moved on to advanced retrieval concepts. Now we are moving to more of transaction management, indexing, performance tuning, security, DBA kind of stuff. I think senior developers would have a good understanding of these concepts as well, but usually these are left out for DBAs. So managing indexes and doing query optimization is a huge game when your data size grows, right? Initially when your data is not high, you don't worry about query optimization, but when your the number of rows returned increase, you typically would want to write a better query. So for instance, these two queries, right? So you have a select star from customers where state is New York and city is equal to New York, right? And then what you have done is rewritten the query in the form of a subquery, which is much more optimized. So subqueries, as I was saying before, this will get you a city is equal to New York, a set of values in there. So this kind of helps optimize the query from an explain perspective. Then you want to do fine tune the database designs, clauses wisely, and there's tons of configurations that you can do when you do query optimization. A lot of it is on the query side, a lot of it is also on the database side. For instance, you can tune your database by increasing your buffer memory, your number of threaded connections, and etc. Connection pooling is a great way, for example, if you're connecting to databases from Python or usually any programming language, using a SQL alchemy and stuff like that could help optimize your query, could speeden up your query typically. Then we move to transaction management, which is commit, rollback, save point, and stuff like that. There's different transaction ISO level: read committed, repeatable read, serializable, dirty read, and stuff like that. We have read all of these about in our college, so I think it's really crucial for us to revisit some of those. Moving on to data integrity, security. So these are more integrity constraints, like I want to when a row from table A is deleted, it should delete from table B also, or some sort of an index based update and stuff like that. These are what constraints are about. Grant and revoke are DCL languages. So these are typically used to manage permissions and privileges on the databases. And then you have some general concepts of database security best practices, which I think you can scan through. So the whole idea is you have started with, and this could be a multi-year conversation as well. I don't want to say that I think you can get from zero to a moderately good level of SQL within a month, but going from that moderate to a very high advanced level could be an year worth of journey. Because initially when you're just working with select queries and understanding and trying to find a best optimized query, that's good conversation initially. But as you mature and as you try to understand the different nuances of writing an optimized query, the amount of time taken to write the query increases, and your own understanding increases. It's also a matter of practice, which is why I say it could be at least a year when you master all of these questions, but can definitely be done earlier too. Then you have stored perform procedures and function. As I was saying, SQL stored procedure is a set of SQL code, which is PLSQL typically is a term used, that can be saved and reused. So basically what you're doing is you're writing an object which is an SQL query, and you just use it as a programmable thing. So here there's an SQL query which can be there's a parameter driven. So I've created a procedure called employee salary, and then get employee by salary, and then when you put the salary there, it will give you the list of employee basis that, and you just say exec procedure name. Functions are similar, very similar. They will return a value or a value set based on results. The scalar functions, there's table valued functions, there's multitude of different operations. A lot of different database products will have the ability to do UDFs, which are user defined functions, and you can do tons of different stuff with that. Then there's performance optimization. As I was saying, optimization is an art and science, I think, both combined. Early days you start by doing key based optimizations, then you understand the importance of subqueries, then you understand advanced concepts like rank and all of that. I think they are covered here, like window functions. Then you do recursive queries, then you work on reducing the number of subqueries, etc. So there's tons of different ways to do performance optimization on query, and this is something you learn with experience. Query analysis is also an area where you kind of look at the query and the explain plan of it, and try and understand how it is actually accessing the data that you are calling for, and you try and optimize for that, given creating indexes and whatnot. Then we move on to advanced SQL concepts. These are really top of the line recursive queries, pivot operation, window functions, table expression, dynamic sequence, dense, row number, lead, lag, tons of different conversations that can happen. And these are very powerful functionalities of databases, and most of the times different database products will offer additional functionalities in these. Most of the stuff that we have talked here are common and ANSI standard, but you definitely can look at more advanced version if you have to refer to a database products. And then from this roadmap, you can definitely go back to the backend roadmap, which I did some time back, or Postgres SQL roadmap, which is a database product, and great idea to look at it. So that's what we had in today's video in the SQL roadmap. If you liked my video, do a thumbs up. Let's start liking my videos, put in a comment. If you love the roadmap conversations, do check out their website. It's really good. I think they're putting in a lot of hard work. Please subscribe. Bye bye.